Well, ladies and gentlemen, in here we would like to present our research. There is a title is 3D object detection and recognition based on RGBD image for healthcare robot. With the team is Ikmalil Birri, Mr. Bima, Sena Bayu Dewantara, and Mr. Dadet Pramadihanto. This is the outline of this research. Yes, there is one is we start with the background, next to the system architecture, then experimental result, and the last is conclusions. So let's start with the background. During the COVID-19 pandemic, the hospital experienced an increase in the number of patients due to the rapid spread of the virus. Therefore, healthcare robot is needed that can help the service of patients and medical personnel in hospitals. In providing services, robot must be able to carry out various kind of tasks, including delivering food, drinks, or drug to patients in the treatment rooms. So the robot must be able to detect and recognize existing objects and be able to put them in the expected place. With this requirement, the system robot must be able to detect object in three dimension, and robot also need to recognize each object that has been detected in order to distinguish between other objects. So this is the system architecture for our system. We divide it by two parts. There is a training pass and testing pass. In the training pass, we start with a training image. That means we collect a dataset that object which relate for healthcare robots or the hospital. And next, we want to remove all unnecessary part using the segmentation. And then we want to extract the feature using the descriptor VFH. That means viewpoint feature histogram. And then we want to training using an artificial neural network methods. And we got the result for model trained, we store it to database. In the testing pass, we start with the 3D acquisitions. In here, we can use RGBD camera or 3D file operations that is captured for RGBD from RGBD camera. Then we want to remove all unnecessary part using the segmentations, and then we want to detection an object using a clustering with the Euclidean cluster methods. And next to the descriptor VFS, we want to extract the filter. After that, we want to prediction using an artificial neural network with the data trained before. And after we got the result for recognition, we want to visualize. Okay, let me start from the training pass with the training images. In here, we collect 9 object dataset that relate for healthcare. There is a ball, box enerphone, there is a box of drugs, and can, glass, infuse, milk box, milk that mean a milk bottle, and the last is plate. And here the visualization of each object I capture on the table. I capture it is 15 degrees. Next, we want to remove all unnecessary, but first we want to filter it using a remove not a number filter, and we want to filter password and using downsample voxel grid filter. And the segmentation we use run segment segmentation method. And here is the result. We have removed all part that is unnecessary, including a planar table, and we got only model of object. Next, we want to extract the feature of each object dataset using the viewpoint feature histogram in the left image. This is the result for box enerphone only objects, and that histogram there is look similar in the right. Here we have a VFS of each object, and there is look very different, and this is very enough for machine learning to recognize. Next, we want to training with the artificial neural network. This is here is the configuration for the INN. In here, in the input layer, we configure with the 308 nodes. There is a relate for the length from the histogram of VFH, and the hidden layer we just have a one hidden layer which is a 616 nodes, and the activation function is segment And in the output layer, we have 9 nodes. There is a count of object dataset that we have collect, and the activation is sigmoid. And here is in the training, we configure it to use 2000 epochs. And here is the histogram result for error, and we got it 29 E-6 error. This is the result for each object that have test, and all have recognized correctly, but keep it. Let's start with the training pass in the input image. In here, we have prepared the 3 scenes. In the sense 1, there is including bowl, plate, mug, glass. In the sense 2, there is the same but in different locations. And in the sense 3, there is a milk bottle 2, milk box, and can. Next, after we prepare the scenes, we want to remove all part there is unnecessary parts. In the sense 1, there is correctly removing, and sense 2 and sense 3 also. So there is no planar table and outliers. And next you want to clustering to detect an object, and here is the result. In the sense 1, we found a fifth object. There is 1, 2, 3, 4, and fifth in here. And the sense 2, we found the sixth object. 1, 2, 3, 4, 5, 6. And in sense 3, we found 4 object. 1, 2, 3, and 4. So this is the result for the object detections. Next, you want to extract the feature of each object, and here is the result histogram with the viewpoint feature histogram in the sense 1 with 5 object clusters. This is the result for sense 2 with 6 objects clusters, and here is the result for sense 3 with 4 object clusters. So after we have a 5 histogram, we want to predict it using the artificial neural network, and here is the result with the console output. So every output nodes of ANN, we want to find the max score, and here is for first object in the sense 1 that correctly recognizing plate with score is 98%. To one see more, in here is visualization. In the sense 1, we correctly recognize bowl, plate, mug, and a glass. And the sense true that correctly recognizing also for bowl, plate, mug, and glass, but there is a noise here recognized as an infuse. And in the sense 3, that is correctly recognized milk bottle, milk box, and can. So in the system, minimal score to visualize is a 35 percentage. So if there are object it that has score less than a 35%, that doesn't draw bunny box and label. This is the result accuracy average for multiple object is a 73%. And here is the result for a single object recognized, and all object has been correctly recognized, and the accuracy average of it is a 98.73%. So here is the result. We have successfully developed a 3D object detection and recognition system based on RGBD images for healthcare robot operations in order to complete its tasks. The object can be segmented by removing some unnecessary part using a few filter and the transplanar segmentations. The system can detect a three-dimensional object using RGBD data with the classification result using the Euclidean cluster, and the result for recognitions show an average accuracy of 90.77% for testing three multi-object scenes and 98.73% for testing single object. This is the reference I have used, and okay, thank you. I hope you enjoy it. Sorry for all the mistake. Goodbye.